Let's start with the key formulas you need for volumes, arc length, and work. First, the disk method. Volume equals pi times the integral from a to b of open bracket f of x close bracket squared dx. Next, the washer method, used when there's a gap around the axis. Volume equals pi times the integral from a to b of open bracket r of x squared minus r of x squared close bracket dx, where r is the outer radius and r is the inner radius. Then we have arc length. L equals the integral from a to b of the square root of open bracket 1 plus open bracket f prime of x close bracket squared close bracket dx. And finally, work done by a variable force. W equals the integral from a to b of f of x dx. Now let's work through an example. We want the volume of the solid formed by revolving y equals the square root of x for x between 0 and 4 about the x-axis. Since the curve touches the x-axis directly with no gap, we use the disk method, and the radius is simply r of x equals the square root of x. So the volume is pi times the integral from 0 to 4 of open bracket the square root of x close bracket squared dx. Squaring the square root of x just gives us x, so this simplifies to pi times the integral from 0 to 4 of x dx. Integrating x gives x squared by 2, so we get pi times the quantity x squared by 2 evaluated from 0 to 4. Plugging in the limits, 4 squared is 16, divided by 2 is 8, and at x equals 0 we get 0, so we're left with pi times 8. That gives us a final volume of exactly 8p. Now the key trick before you write any integral, always sketch the 2D region and the axis of revolution first. If the region touches the axis directly, use disks, like we just did. But if there's a gap between the region and the axis, you need washers, with an inner radius accounting for that gap. Here's the most common trip-up. When using washers, students often compute r minus r first, then square that whole combined bracket. This is a sign and structure error. Squaring r minus r as one quantity is not the same as squaring r and squaring r separately and then subtracting. Mixing these up silently gives you the volume of the wrong solid entirely. So here's the teaching tip to avoid that mistake. Write r of x squared and r of x squared as two separate, fully expanded terms, each on its own line, before you subtract them. Never square a combined bracket of r minus r. Always square each radius on its own first.